All right, guys. So we're going to take back up where we left off yesterday, working on the unit circle. And here we filled out the unit circle yesterday in quadrant 1 from 0 degrees all the way up to 90 degrees and came up with all the coordinates, okay, that show up on the unit circle. So today we want to work in quadrant 2, and then we'll take care of quadrant 3 and quadrant 4 later on this week. So once we leave quadrant 1, we have to use what are called reference angles, okay? Our reference angle, okay, is used when you rotate from 0 degrees, okay, counterclockwise past 90. So you rotate out of quadrant 1, okay? So if we were at 0 degrees here, obviously it's 360 all the way around, so this would be 180 degrees. Okay, and obviously this is 90 degrees straight up. So if I rotated 135 degrees, so this guy right here, my theta is 135 degrees. Notice that I've gone past 90 degrees, okay? So we have what's called this reference angle, okay, in here, okay? And notice that the angle of rotation and the reference angle, okay, will add up to 180, okay? Notice that right here, all I'm doing to get this 45-degree reference angle is going 180 degrees minus 135 degrees to get that 45 degrees. Okay, now why is this important, okay? Well, it's actually pretty easy to show you why it's so important. Okay, let's suppose, okay, we are, okay, in this unit circle. Okay, let's suppose this is you. Oh boy, that's a bad looking guy. And let's suppose I rotate from 0 degrees and I just rotate, let's say, we'll go 45 degrees. Okay, so I have this 45-degree angle of rotation. Well, if I drop a vertical line down, okay, I get a 45-45 right triangle. Okay, which obviously is one of our special triangles. Now let's suppose that I rotate 135 degrees. Okay, so that guy's over here. So that would take me all the way like this at 135 degrees. Well, I want to form a right triangle, so I would have to drop straight down here. And that would give me a reference angle of 45 degrees here. And notice, this is a 45, 45, 90, and this is a 45, 45, 90. So this guy here is just a reflection of this guy. So if I had this point, you know, whatever you call point P right there, well, this point right here would be a reflection of that. Okay, so we would have the exact same coordinates, except we would just account for the fact that we're in quadrant 2 rather than being in quadrant 1. Okay, so these reference angles are real important. And we have some rules for finding them, and they're pretty easy to do, okay? All right, so a reference angle, you know, we're using this theta, okay, as our angle of rotation. So a lot of times with a reference angle, we'll use a Greek letter and we use alpha, although there's no rule that says you have to do that. It's just kind of common practice. Okay, so if we're in quadrant 2, okay, so if we've rotated past 90 degrees, but we haven't hit 180, so we're in quadrant 2, your rule for your reference angle is just 180 minus whatever your angle of rotation is. So if I rotated 150 degrees, I'd have a reference angle of 180 minus 150, or 30 degrees. Okay, if I'm in quadrant 3, so I've gone past 90 and past 180, and now I'm down in quadrant 3. Okay, so now your theta is greater than a 180. Your reference angle would be theta minus 180. Okay, so if I say had 225 degrees, okay, so I go past 90, past 180, down to 225. My reference angle would be 225 minus 180, or 45 degrees. And then if I go all the way past 270, so I'm over into quadrant 4, okay, you would go 360 minus your angle of rotation, 360 minus theta, to get your alpha. Okay, so it's some pretty easy stuff, I'll be honest with you. Okay, so just for instance, let's suppose we just take a look at a couple of these. I don't know, we don't have to do all of them. We'll do this guy right here. Okay, we will do this guy right here. Okay, let's see, and we'll do, how about this guy right here? We'll do them. Okay. Let's get one more. Let's get this guy right here. We'll do those four. Okay, so, okay, 100, let's see. This. Okay, so if I'm in my unit circle, and 0 degrees starts up here, 90 degrees would be due north, 180 degrees would be due west, and 270 degrees would be due south. Okay, so if we're looking at 164 degrees, notice that's between 90 and 180, so we are in quadrant 2 here. Okay, so this guy means we're in quadrant 2. Okay, so we go to our rules. What do we do in quadrant 2? Well, quadrant 2 says we go 180 minus our angle of rotation, 180 minus the theta. Okay, so our reference angle for 164 would be 180 pesos minus 164 pesos, which would give us, what, 16 degrees. So our reference angle would be 16 degrees. This would be your alpha, okay, right here, 16 degrees. Okay, here we're at 203 degrees. Okay, so let's see, that's past the 180, but haven't hit 270, so it's down here in quadrant 3. Okay, so right here, we're in quadrant 3. And we say, okay, what are our rules for quadrant 3? Well, quadrant 3 says you go the angle of rotation, our theta, minus 180. Okay, so we would go our angle of rotation, 203 pesos minus the 180 pesos. So it looks like we're gonna get what, 23 degrees? So 23 degrees, that would be my alpha. Okay, right there, my reference angle. Okay, 300 degrees. Well, that would put us into quadrant 4, right here. So we say, okay, well, what's our rule for quadrant 4? Well, quadrant 4 says that we go 360 minus our angle of rotation. So it'd be 360 minus theta. Okay, so I would have to go, okay, 360 minus the 300. Okay, and obviously this guy is in quadrant 4. Okay, so I'm gonna get a 60-degree reference angle. So that's my alpha, right there. Okay, then 289. Well, once again, 289 is in quadrant 4. Okay, so once again, I have to use the same rule. I would have to go 360 minus 289. Okay, and what's that gonna give us? 71? Yeah, 71 pesos. So that would be my alpha there. Okay, so it's really just some really easy rules. Okay, so a lot of times when we first start talking about reference angles, some kids need to keep referring back to these rules. But after you use them a number of times, you just remember them off the top of your head. They're pretty easy to remember. Okay, so just keep referring back to this as much as you need. Okay, all right, so now we get into quadrant 2 on the unit circle. Okay, and we're going to start with a 120-degree angle. Okay, so notice that takes us into quadrant 2. Okay, that's quadrant 2. Okay, because that's between 90 pesos and 180 degrees. Okay, so that guy would be about right here. Okay, so that takes you the 120 degrees. So we're in quadrant 2, so our reference angle, our alpha, our rule, which tells us in quadrant 2 we go 180 minus theta, which is 120. So that gives us a 60-degree reference angle. So that means when I form this guy, that's 60 degrees. Okay, that means it would be a reflection of the guy over here formed by 60 degrees. Okay, so we go say, what's going on here? What's going on here? So we go to our unit circle, and notice 60 degrees, that point is at 1/2 and radical 3/2. So this has to be 1/2 and radical 3/2. Okay, so this guy is a reflection of that guy. Okay, so this guy right here has to have these coordinates, except we account for being in quadrant 2. And let's see, when we're in quadrant 2, we go to the left and up. So that means our x coordinate will be negative and our y coordinate will be positive. So that gives us a negative 1/2 and a radical 3/2. And that takes care of the next important angle in our unit circle. Okay, so we can go to this guy and see, and that's the first special angle past 90 degrees. So this is 120 pesos, right? Which obviously has a reference angle of 60 degrees, and that is at negative 1/2 and radical 3/2. So this would be a negative 1/2 and positive radical 3/2. Okay, so that would mean, once again, the cosine of 120, okay, is negative 1/2, and the sine of 120 is radical 3/2. Okay, all right, let's see. Our next guy, 135 degrees, once again in quadrant 2, and that's all we're working at. We're working with quadrant 2 today. So let's see, my theta, I would have to go past the 90 degrees, but I'm less than 180 degrees. So that 135 would be about right here. Okay, so I have this angle of rotation of 135 degrees. So we say, okay, drop my vertical line down. So I got a right triangle. Okay, this is 135, so what's this reference angle in here? So my alpha in quadrant 2, we say 180 minus theta, which is 135. So I get a reference angle of 45 degrees. So that means that this right triangle is a 45, 45, 90. Okay, and it has to be a reflection of a 45, 45, 90 in quadrant 1. Okay, so that means this point right here and this point are reflections of one another. So we say, okay, well, what's that point at 45 degrees in quadrant 1? Well, that guy is radical 2/2 and radical 2/2. We did that yesterday. So that means this guy is radical 2/2 and radical 2/2. Well, this guy is a reflection of that guy, except we're just in quadrant 2, and in quadrant 2, your x-coordinate is negative, your y-coordinate is positive. So this would be negative radical 2/2 and positive radical 2/2, like that. So we have our next important angle measure, okay, on the unit circle, 135 degrees. So let's see, we'd rotate all the way past, so this would be 135 degrees. And we are at negative radical 2/2 and positive radical 2/2. So that means the cosine of 135 is negative radical 2/2, and the sine of 135 is positive radical 2/2. Okay, let's see. Last guy in quadrant 2, 150 degrees. Okay, so again, we have 90 degrees straight up, we have 180 degrees due west. So 150 degrees would have to be about right here. Okay, and that's my 150 degrees. Okay, we're still in quadrant 2. So I've got my right triangle here, and I need this reference angle in here. So we're in quadrant 2, so my alpha, my reference angle, is 180 pesos minus 150 pesos. So I get 30 pesos. So my reference angle in here is 30 degrees, which means that this right triangle has to be a reflection of the right triangle in quadrant 1 with a 30-degree angle there. Okay, so this point here and this point here have to be reflections of one another. So I go to my unit circle, I say, okay, well, what's happening at 30 degrees? Well, the coordinates are radical 3 over 2 and 1/2. So this guy is radical 3 over 2 and 1/2. So this guy has to be the same as this guy, except we account for being in quadrant 2, where your x coordinate's negative and your y coordinate's positive. So this guy would have to be negative radical 3 over 2 and a positive 1/2. Okay, and we have, okay, our last important angle of rotation in quadrant 2, that's 150 pesos, okay? That's what we're working on here, 150 pesos, okay? And that has coordinates negative radical 3 over 2 and 1/2. And 1/2, okay? So all we have to do is come up with this guy, okay? But we know going all the way around is 360, okay? So a semicircle, half of it would be 180 degrees. So we know this is 180 degrees. And remember, we're on the unit circle, the radius is 1, so that's 1 to the left. So the coordinates there would just be negative 1, 0. Which is nice, because that means the cosine of 180 is negative 1, and you could check that on a calculator. And the sine of 180 is 0. Again, you could check it on a calculator. Okay, so we have the northern hemisphere done. Okay, and so tomorrow we'll come back and we'll work in quadrant 3. Okay, you guys stay safe, and I miss you a whole bunch.